we said a disaccharide is two monosaccharides put together. So in dehydration reactions, when you join monosaccharides, two monosaccharides is going to form a disaccharide. The bond between each monosaccharide is a type of covalent bond that we call a glycosidic linkage. Now here is a photograph of a dehydration reaction at the top. We're synthesizing maltose. If you put two glucose molecules together, you can see that glucose is in a ring, and if you add two together, then an OH from one end and the H from the opposite end of the next glucose molecule are going to produce a molecule of water, and we're going to end up with a disaccharide called maltose. And you can see that this linkage in between here from this oxygen is going to be your glycosidic linkage. Now they call it a 1,4 glycosidic linkage because in this particular instance, the one position is the first carbon here, and in the other molecule, it is connected to your fourth carbon. Dehydration reactions in the synthesis of sucrose. Sucrose is commonly known as table sugar, and this one you put a glucose and a fructose together. So we know that the glucose has the OH on one end. We take the H off of the fructose on the other. A molecule of water is released, and here you can see now actually we have a 1,2 because fructose is actually got a different configuration. So in counting in this direction, we have got the second carbon and we have got the one from glucose. All right, polysaccharides, these are polymers of sugar, and they have very powerful storage and structural roles. We do store our carbohydrates when we're not using them. If we eat really, really long chains of these polysaccharides, it takes our bodies a while to break it down. The architecture and function of a polysaccharide is determined by each one of its sugar monomers and the positions of those linkages. So we can hook, there's all kinds of sugars, guys. There's maltose, that's malt sugar. There's sucrose, of course, that's table sugar. Galactose, glucose, fructose. Lactose, that's milk sugar. There's all kinds of different kinds of sugars, and depending on how many you have and how they're linked, meaning where the position of those glycosidic linkages are, will determine how difficult it is to break this particular carbohydrate down. For those that are hundreds and hundreds of monosaccharides hooked together, then our bodies obviously need some time in order to break those down. Whereas if we have something that's only 3 or 4 glucose molecules long, they're very short, they're very sweet. Obviously, something like Skittles, honey, things like that, we can break down very quickly and we get the energy from those bonds right away.